Hi, my name is Daryl. So I'm gonna explain about the question 3. Why does the stream of water from a faucet become narrower as it falls? So why does this happen? The answer is really simple, and a few simple principles need to be known and understand the behavior of the stream. So first, we assume that the flow is steady. So by that, we mean that the flow does not change in time. The stream stay and behave the same from one moment to the next. So the amount of water in any section of the stream stays the same. This leads us to the next step. The amount of water that is entering any section must equal to the amount of water leaving any section at a time. By that, it means that the more the cross section there is, so the more the flow will be.
Hi guys, my name is Fatin Farhana and today I would like to explain to you guys about the speed of the flow at the faucet. Stay tuned. Okay, let's restart. Now, I want you to go to a sink or a bathroom or somewhere you have access to a water faucet. Turn that faucet on. Take a look at the water as it falls down. You will notice that it doesn't look like this as you might expect. In reality, the water tapers off. It gets thinner and thinner as it falls. So after it has fallen in the distance y, the initial radius r has reduced to small r. If I draw an imaginary ring here and let the water pass through both of them, if 1 liter of water passing through this ring every minute, none of the water is splashing off to the side. So it must be the case that water's flow rate is constant. You can also show that this flow rate is equal to the velocity of the water through a given ring. Third, we have to assume that the water leave the faucet already has some velocity, is moving downward at V0.
I'm Muhammad Ammar Bakir Benzul Nazruddin from BMMV 2/1. I would like to present about amount of water entering section. So the amount of water entering any section of the stream must equal the amount of water leaving that section at any time. So the amount of water running through the cross section of the stream per unit time at any point is the same. This is obviously depends on the cross section. The more cross section there is, the more flow there will be per unit time. For the example, with a highway, the wider the highway, the more traffic it can accommodate. So we can come out, the formula of amount of water entering section is A1 is equal to A2.
We arrive at the following equation. P1 times with V1 times with A1 equals to P2 times with V2 times with A2. P1 and P2 are densities. V1 and V2 are velocities. A1 and A2 are areas. Where P1 and P2 are density at the two cross sections in equation V1 and V2 and A1 and A2. As mentioned before, the density of water is pretty much a constant. So we have P1 equals to P2, which leaves us with V1 times with A1 equals to V2 times with A2. Now our observation suggests that at lower points in the stream, the cross section is smaller. The stream is narrower. For the last equation to hold, it must be true that the velocity at the lower part of the stream must be higher so that the product remains the same. How that can be? The answer is simple. Gravity. Like all objects, a stream of water also accelerate as it falls. Since the density of water is constant and water tends to hold together, the only thing that can happen in the narrowing of the stream, which is exactly what happened.
Hello, my name is Ahmad Farooq and I will discuss question 3 in assignment physics. From the figure question 3, we know that the water leaves the faucet conservation of energy, which is kinetic energy and potential energy. We assume that velocity initial equals to velocity final. So, we derive our kinetic energy initial equal to kinetic energy final. So, at the left hand side, we have 1 over 2 times mass of water times velocity initial square equals to 1 over 2 times mass of water times velocity final square minus mass, gravity and height. Okay, so since the value of m at the left hand side is equal to m at the right hand side, so we can cancel out. So we need to choose one variable from other so we need to choose one variable as a subject. For example, in this equation, we choose velocity final as a subject. So we got the first equation. So in equation 2, we assume that horizontal cross section are circular both sides and multiply it with pi r square. So we use formula density, area times velocity. So we know that rho final equal to rho initial. So we got this equation and then we derive it and make D as a subject. So this is the second equation. So for the next step, we substitute equation 1 into equation 2. So this is equation 1 from the early one and this is the equation 2 from the above. So we substitute it and we got this final equation. Thank you from me.